There you
All right. Where should we start?
go. I guess at number 13.
All right.
We're back to number 11, so we could do a little review of the sign and stuff.
Okay. As we go to negative infinity, notice what sine and cosine do as you go to infinity or negative infinity. They both fluctuate between 1 and minus 1, right?
Mm-hmm.
Okay. So the only figures that matter are the minus t in the numerator and the t in the denominator. And if that was infinity over infinity, then we would not know what this limit is. But it's not. Notice what it is. It is minus t. In other words, the only thing I'm really going to pay attention, it's kind of like when you have a polynomial and you only deal with the highest degree. This is similar. What is the limit of that as t goes to negative infinity?
Would it be negative infinity? Or no, would it be 0?
Be negative 1.
Okay, negative 1.
Hold on a minute. Let me think for a second. Well, it's the ratio of the coefficients, right? In other
Yeah.
words, let's see. If I do direct substitution, I get positive infinity divided by negative infinity. Well, that's kind of indeterminate. Do you have answers on these?
Only for the odds.
Well, that's an odd, 11. This is a little bit of a
I'll look it
strange
up.
one. I don't see these very often. I thought we did this last week, and you looked it up, and I'm pretty sure the answer was negative 1. Um,
No, no. It's negative 1.
yeah. And it's kind of like this. If I had 3x squared minus 100x divided by 2x squared plus 1,000x, and I want the limit of that thing as x goes to infinity, well, the only thing we care about is that. We can ignore everything else. In other words, we deal with the highest degree polynomial only, and it's the ratio of the coefficients. If the degree is the same, in other words, this is an x squared, this is an x squared, so as we go to infinity, those cancel and we end up going to 3 halves. Well, same thing up here. And it wouldn't matter whether it was t over minus t or minus t over t. The ratio of those coefficients is minus 1.
Okay.
Okay. 12, what would that be?
So, R plus sine R, so to infinity.
Well, you can ignore those because sine doesn't do anything but this. So sine goes between minus 1 and 1 as you increase the number. So that's kind of like the x in the previous example that I just wrote. We don't care any of this. The only thing we care about is the r over the 2r. What does that do?
That would be 1 over 2.
That's right.
Okay.
So number 13. What's that go to?
So that would be 2/5.
Number 14.
2.
Yeah, and neither of these matter whether you're going to infinity or minus infinity.
Okay.
Well, I'm not saying it doesn't matter throughout all 20, through 22, but with 13 and 14, it doesn't matter. It's going to go to 2/5 on 13, whether you're going to infinity or minus infinity.
So it's always that way?
What's that?
So it's always the same either way?
Well, no, that's if the degrees are the same. In other words, this is x over x. 14 is x cubed over x cubed. 15 is not. 15 is x over x squared. What's the horizontal asymptote?
Oh, would it be 0?
Correct. And horizontal asymptote means that's what it goes to as x goes to infinity, as it goes to the horizontal asymptote. Now, as it goes to negative infinity, it'll still do that. It'll still go to 0. And the real way to prove this is to graph it. Let me bring up Wolfram alpha, because if you graph it, you can see where it goes to when you're going to positive and negative infinity.
Okay.
The negative infinity, I'm not sure if that matters. I don't think it does in, it might in 15, because the negative infinity in the denominator squares goes to positive infinity. I don't know, I'm curious as to what this graph looks like, and we can see what happens as it goes. You're allowed to use a calculator to answer these or not?
No, I'm not.
No, you're not?
No, not on this quiz.
Okay. I'm going to use one anyway, just to prove to myself that we're doing it right. You can see, first of all, I know that as it goes to positive infinity, it's going to go to 0. No question about it.
Okay.
What does this graph tell us? Hold on, it's only going to give us, no, it gives us both. Look at the bottom graph. What happens as we go to negative infinity?
It looks like it stays just under 0.
Well, it's headed towards 0. In other words, it's going to 0 also.
Okay.
So if the bottom blows up, in other words, because it's x squared and the top is only x, well, the bottom's clearly going to blow up much bigger. So you're really dealing with a number over infinity, which goes to 0, whether it's negative infinity or positive infinity. 16. What's that go to?
Would it be 0 as well because the bottom's bigger?
Yes. 0 in both directions. 17. What's that go to?
7.
Okay. And negative infinity?
-7.
No, I think still positive 7.
Even though it's 3 to the third?
Yeah, and I'll prove it to you by graphing it. And the only part I need to graph is the 7x cubed divided by x cubed. Notice the x cubes cancel. Oh boy, I got all this other stuff here. Hold on. In other words, this is, if you were to just reduce this, it would reduce to 7, right? On 17?
Yes, I believe so.
Interesting that it doesn't graph. They graph it strictly on the number line. Huh. Well, maybe I need a y equals, and then it'll graph it for me. Y equals. It's going to graph a straight line at 7, yeah. Yeah, horizontal line. In other words, the x cubes cancel, and it doesn't matter whether you're going to infinity or not. The function goes to 7 no matter what these are. Okay. Let's see if we can find one. I thought we found one the other day that didn't necessarily go to the same number when x went to infinity as it did when x went to negative infinity. But we'll get to it. 18 is what?
18 would be 9 over 2.
9?
Yeah, 9 over 2.
19?
That would be 0.
Okay. 20 is different.
Yes.
Notice 20, we have x cubed over x squared. So the top blows up before the bottom. In other words, if I simplify that, that goes to x. Well, what does g of x go to as x goes to infinity?
It would go to 0.
No. Top blows up.
Okay.
That means the whole function goes to infinity. In other words, if I were to write 20, I would basically be looking at x cubed over x squared. Well, that's equal to x. So as x goes to positive infinity, y goes to positive infinity also. In other words, here's what we have.
Oh yeah, it's a graph that goes, the right goes up and the left goes down.
Right. So here's the one that's different. What happens as x goes to negative infinity?
Y goes negative infinity as well.
So there's the first one we've seen that has a different answer for positive infinity as opposed to negative infinity. Okay. 21?
So it's 3x to the 7th over 6x to the 3rd.
Right.
So that would be, when I subtract the exponents and make it over, or x to the 4th.
Okay, so this is basically what we're looking at. And what's the limit of that as x goes to infinity?
Infinity.
What is it as x goes to negative infinity?
Infinity.
Right. And 22. Oh yeah. Didn't we do these last time?
I didn't do all of them.
I've done 22. Oh, maybe we jumped to 20
Yeah, we jumped
when we ran out of time. 22 is an interesting one because that negative 4 actually matters. In other words, what we're really looking at is 5x to the 8th over minus 4x to the 5th. Well, I don't know that it matters or not. I thought it did last time we looked at it, but it really doesn't, does it? In other words, as x goes to infinity, the whole thing goes to infinity, and as x goes to negative infinity, the whole thing goes to what?
Infinity?
No. Negative infinity.
Negative infinity cubed.
Any negative number cubed stays negative. In fact, any negative number to an odd power stays negative. Huh, interesting. I used different logic last time when I looked at this problem to figure out that it went to negative infinity. But now I'm not totally convinced that it's not reversed. In fact, I think it is. The fact, yeah. In other words, what this really turns into is that, is it not?
Yeah, I believe so.
which means as x goes to positive infinity, this whole thing goes to negative infinity. And as x goes to negative infinity, the whole thing goes to positive infinity. In other words, it's the reverse. It's the reverse of what x cubed would be. So even if the top blows up relative to the bottom, you still have to consider not the coefficients, but the sign on the coefficients. In other words, I don't care about the 5/4. What I care about is that one of them is negative. And when I simplify that thing, I get negative x cubed. And that changes both answers. It reverses the answers, basically.
Okay.
Okay. Now, with 23 next?
Yes.
Okay. What do you think that goes to?
8/2. But it's square rooted, so it would just be a normal 8/2.
Well, that's 4.
Yeah.
But you got to take the square root of that.
So it'd be 2 afterwards.
I think so. Can you look that up real quick?
Yep. It says 2.
Yeah,
Correct.
2. And then 24 is going to be what?
24 will be 0.
No. What's the ratio of the
Oh, no. Never mind. Oh, 1/8.
And then take the cube root of that.
So 1/8 times 1/3, 1/24.
Hold on. When I say take the cube root of that, first thing is it's the cube root of 1 divided by the cube root of 8. Well, the cube root of 1 is 1. What's the cube root of 8? 2.
So it'd be 1/2.
So that whole thing goes to 1/2. So when you have a exponent, in both of these problems, this problem basically we have the whole thing to the 1/2 exponent. You do have to consider the exponent when you're looking at that ratio of coefficients. In other words, you do have to apply the exponent to that ratio of coefficients. Whether it's 23 or 24, that's what we did. We took the ratio of the coefficients and then we applied the exponent to it.
Okay.
Okay. You got another page? Only got 7 minutes, but...
Yep, I emailed you the other one.
Okay. I like your stuff because I always get stuff that I don't get anywhere else. Nobody else gives me problems like this. And
Yeah, my school doesn't follow the Common Core.
They're kind of fun. Well, once you figure out how to do it, they're fun. So 25 is going to go. What's going to happen to 25?
So it'd be x cubed over 2, or x squared.
Well, it'd be negative x cubed over x squared, which simplifies to x, negative x. And then because we have to take it to the 5th power, it goes to negative x to the 5th. And now what happens is x goes to negative infinity.
Okay.
What does it go to?
Would it go to negative infinity because it's x cubed?
No. Well, no, this is what it is right there.
Okay.
Because we do have to apply that exponent we saw in those 2 previous problems. But in this case, when you take minus x to the fifth, when you take it to an odd power, well, infinity would go to infinity and negative infinity would go to negative infinity, but I got that minus sign right there. In other words, just like in question 22, I didn't care about the 5/4, but I did care about the -4. That minus sign changes what this simplifies to and what that simplifies to, and having the minus sign inside the parentheses means that minus x to the fifth becomes the same as minus x to the fifth. Well, if I deal with just that part, when x goes to infinity, that whole thing goes to infinity, which means the whole thing goes to minus infinity. And when I plug in minus infinity, that whole thing goes to minus infinity with two minuses, then it's plus infinity.
Okay.
You understand what I'm saying?
Yes.
Okay. 26.
So that would be 0.
Yeah. 27.
I could make instead of having it as a square root of x, I could do x to the 1/2.
Yes.
And then I would have x to the 1/2 over x.
Yes.
And what would that bring it to if I'm subtracting?
Well, which is blowing up? In other words, we basically have x to the 1/2 over x. That's 1 over square root of x. Now what happens as x goes to infinity?
Okay.
The denominator is blowing up. So what's the whole thing go to?
Infinity?
0.
Oh, 0. All right.
You knew that.
Oh, yeah, because the denominator is larger. Okay.
Yeah. In other words, if I've got 1 over x, what happens? What's the limit of that as x goes to infinity? Well, that gives me 1 over infinity, which is 0. Whenever the denominator goes to an infinity and the numerator stays the same, the whole thing's going to 0, whether it's plus infinity or minus infinity. It's still going to go to 0.
Okay.
Okay. 28.
So I do the same thing, x to 1/2 and x to 1/2.
Hold on. The highest power in the numerator is the same as in the denominator. So
Correct.
what's the horizontal asymptote, which is the same answer as what's the limit as x goes to infinity?
1 or 0?
The ratio of the coefficients. I got a +1 over a -1.
Correct.
So that's going to go to -1.
So the asymptote would be -1?
Yeah, it would be. Basically, here's what I have. Square root of x over minus square root of x. And there's a 1 there and a 1 there. So here's what it's going to, right there. In other words, you do have to consider the signs. The signs are almost more important than the numbers. I mean, if you know what I'm saying.
Okay, now I understand it, because it's the same thing, because there's a negative that overpowers the positive.
Right. In 22, we had +5 over -4. Well, I didn't care about the 5 and the 4, but I cared about that's going to make it negative.
Okay.
And that makes a difference as to what it goes to. All right.
Got it.
It's 7. You want to go, or you want to do some more of these?
I can do a few more if you have time.
Okay. 29.
So it looks like the largest would be to the third.
So what's it go to as x goes?
Over 1 or 2.
Well, the question is it 1 or negative 1?
Because it doesn't look like there's a negative sign in front of it, however, it's a negative infinity.
No? Oh, there is definitely a negative sign in front of that. So the question is, what's the limit of this thing as x goes to negative infinity? Well, I still think the answer is 1. Can you look it up quick?
Yep, 1 second.
Yeah.
It's 1.
Yeah, because even if I substitute negative infinity here, well, the cube root of negative infinity is still negative infinity. And the cube root of the bottom is negative infinity. So now I got negative infinity over negative infinity. That's positive. So it's going to go to positive 1.
Okay.
30 is interesting. I'm not sure I've ever seen one where they're all
Different ones.
well, they're all negative exponents. So basically you have 1 over x plus 1 over x to the 4th, all divided by 1 over x squared minus 1 over x cubed. Now, well, you know, let's see what happens. We'll do this one and I'll let you go. I've never encountered this, but I think I know how to do it. Let's find a common denominator. So the top becomes x to the 3rd over x to the 4th plus 1 over x to the 4th. And the bottom becomes x over x cubed minus 1 over x cubed. So this, now if I flip and multiply, I get x cubed plus 1 times x cubed all over x. That's the same as x to the 5th. What's that go to as x goes to positive infinity?
That'd be positive infinity.
Yeah, surprisingly, huh? Wonder if I made a mistake in my math here. Because this term looks like it would go to 0. This would go to 0. You'd have 0 plus 0 over 0 minus 0, which is 0 over 0, which you never know what that's going to do. That's kind of indeterminate. So I do think you have to do it the way I did it here. In other words, yeah, you have to actually add those fractions and make it a single rational quotient divided by another rational quotient so that I can flip and multiply. And when I flip, oh, I forgot to move the x to the 4th over here. I've still got an x to the 4th in the denominator, and it becomes x to the 5th, so the whole thing goes to x, not x to the 5th, but the answer is the same regardless. Still is going to go to infinity. Yeah,
Okay.
you got to do the math right. I didn't do the math right. In other words, I've got x cubed plus 1 over x to the 4th multiplied by x cubed over x minus 1. and that gives you x to the 6th in top, gives you x to the 5th in the bottom, going to go to infinity.
Okay.
Okay? All right.
Well, thank you for spending extra time to help me.
Yeah, no
And my
problem.
mom also wanted to know if you received the payment that we sent in.
I got one a week or two ago. Yeah.
Yes, last week.
Yeah. Yeah.
Okay.
I
I
did
just wanted to make
tell her.
sure.
I appreciate it. Thank you.
Okay, thank you. Have a good evening. See you next week.
Okay. Bye-bye.